DesignCon is the biggest event in the EDA industry. It brings together design experts for both very technical discussions as well as networking opportunities.
Pretty much everybody in our industry, come here and then share the ideas, and then network, and then just get into this expo is quite exciting.
Yeah, I love talking to the industry experts for just general technical chit-chat and find out where the industry is heading. We're presenting a new design idea that can help alleviate the space constraints in high-density memory applications for embedded systems. This is relying on connecting the memory to the controller through a flexible PCB and an interposer. And the paper focuses on examining the effect that this interposer and the flexible PCB has on the signal integrity of the DDR4 high-speed signals.
For those that the system we're looking at, we directly put that memory chips on that board. It takes a lot of real estate area. And then for the high memory systems, it's just taking 30%, maybe up to half of all the real estate. So we're trying to somehow relieve the real estate problems by adding that flex PCB.
So we're basically getting the best of both worlds. We have the space saving that a DIMM socket would give us, but at the same time we have the reliability of a memory down approach.
Oh, and also for the electrical reasons, we have an interposer directly connected to that flex PCB. So we don't have a connector. So the connector always presents a lot of problems in high speed. So we eliminate that, and then we have a much better system design.
The flex PCB itself, I mean the fact that it's flexible does not affect the signal integrity too much. Actually has a very, very small effect. The main effect comes from the number of layers that you would use in the flexible section. We found that if you use only 2 layers, one ground, one signal, we need to route very densely, which increases crosstalk. We hope that this would be eliminated by using more layers in the flexible region.
Our paper focus mainly said, well, flex means that you can bend it, so there's always the radiation issues. So that the paper really showed that there's not much of a concern for most of the part. And another issue was that we have to, depend on that, how big is that the flex PCB and how many layers you use, you may have to put the routing so tightly together. So that will present a lot of issues. But that's something we're looking at. Adding more layers will always eliminate that the crowdness. Normally adding layers is a cost adder. But so far we find that there's not much of an issue for the cost adding layers. So maybe there's a possibility. We only looked at the 2 layers, but maybe 4, 6 layers, get everything spread out, maybe everything look good.
Designers should keep in mind that they're exploring new terrain when they're routing high-speed signals on flexible PCBs. And we highly recommend that they use simulation to avoid any surprises later on in the design process.
Oh, and also, not just the flex, but the connection. You got a flex PCB and also go to the rigid. So make sure that you have enough of the stitching vias to make sure the return pass is all good. So not just the routing a signal itself, but enough ground. If it's a ground reference, then make sure the ground via is adequately there.
Well, everything is getting faster, right? Which is good for us, because the faster it gets, the more people will need simulation.
Yeah, faster and then going larger scale, like at the system level simulation. Like 10 years ago, most of the sessions they talk about it, they used to simulate the one section at a time and then put in a spice and simulate it. But now, like a company like his, CST, trying to put everything together and then boom. I'm excited to see in 10 years maybe it will be much easier, to run the simulations.
Well, we've heard many good things about Sierra circuits, about their rigid flex capability and their prototyping capability. And yeah, we're looking forward to exploring a collaboration with them and maybe even on the DDR4 interposer.